I think we're live.
Hello.
All right. I think we're live, Leonard.
Are we live?
I think so. I hope so.
I hope so.
If not, we'll have a live chat via the YouTube channel. So there's always a possibility to ask questions. But for now, welcome to the DataWorks meetup about workflow engines. I think it's an exciting topic. We have a lot of subscribers for that. And I actually have made my first workflow problem when I was working for data for bol.com, where we had a data load that was running for 10 hours. And it was often the reason why we could not go live with the whole shop. And one of the reasons why actually bol.com decided to go for continuous delivery, split up the data load in lots of different workflows. And I think now we're 10 years on, and I'm very curious about the next generation of workflow engines. We'll be hearing presentations about Argo and about Temporal. So I guess one step higher about, or newer than Airflow. I'm very curious what we'll learn about that. If you have any questions, please send them to the live chat, and I will ask them to the presenters. And yeah, I hope that you'll enjoy the next hour with our two presentations from Leonard and from Peter. And Leonard, I'll give the microphone to you.
Thank you very much. Hello everyone. I'll be talking about Argo Workflows and what Argo Workflows is. Not to be confused, by the way, for the people who have seen it with Argo CD, which is a continuous delivery tool. Argo Workflows is a workflow engine. But before I get started, let me first introduce myself. Who am I? I'm a data engineer at DataWorks. I'm also an open sourcer. What that means is I really enjoy both working with open source technology as well as contributing and maintaining open source technology. You can find my GitHub here, blokje 5. And you can find me on Twitter as LeonardNL. And of course, if you're interested, you can also visit my website, blokje5.dev. For the people interested who want to follow along with the demos I will be showing during this talk, I prepared a GitHub repository where you can see all the code, all the demos, and have like a local environment where you can play around with Argo Workflows. So if you're interested and want to follow along during the talk, or if you want to look at it when the talk finishes, you can follow that link. Okay, what is Argo Workflows? Argo is a container native workflow engine. It utilizes Kubernetes under the hood as the container orchestrator, and it extends Kubernetes with the concepts of workflows. Argo is implemented as a Kubernetes operator. A Kubernetes operator consists of two components: a custom resource, which extends the Kubernetes API with new custom resources. In the case of Argo, it extends the Kubernetes API with the concept of workflows. And a Kubernetes operator consists of a controller. A controller is responsible for watching the Kubernetes API and watching for any changes to, in this case, the workflow. So in this case, the custom resource workflow. It then changes the state in the cluster to reconcile the desired state as defined by the workflow and the actual state, which is the workflow running within your cluster. So the workflow controller, whenever you as a user define a workflow, will spin up multiple pods in a sequential order. And a pod you can essentially just see as a Docker container with a few extras in Argo's case. So besides your main container, so where your application logic, where your workflow logic resides, Argo also has what is called a wait container. This is used internally by Argo for watching when your workflow step completes, whenever for watching any artifacts it might generate, so your workflow might generate some files, and the wait container will fetch those files and pass them along, as we will see later on in the demo. Besides that, Argo comes with a UI, which is just like a nice website where you can watch your workflow progress, where you can debug any errors that occur, where you can check the definition, and where you have a history of all the workflows you executed with Argo. And we'll show that in the demo later on as well. And then the final component is the Argo CLI, which is mostly a nice interface to interact with Argo, to create workflows, to change parameters, to start your workflows, etc. So let's get started with the first demo, because I like to do things demo driven. Let me zoom in a bit, because otherwise I think it's not readable for most of you. Hopefully this is nice and readable. So first of all, I'm running a local Kubernetes cluster. I'm always double checking if I'm not connected to whatever production cluster. This wouldn't be the first time that I did my demo on a production cluster, which I definitely cannot recommend. And what we'll do now is we'll install Argo into our local Kubernetes cluster. A couple of notes on my local installation. I'm using, as you can see, the NGINX controller. This is mostly so that I can later on connect to the Argo UI. And there's one specific note about configuring Argo on a local cluster, which is that you need to configure the container runtime executor, which is an Argo internal detail about how it interacts with your containers. By default, it uses Docker, but that doesn't work when you're running Docker in Docker. It gets messy and Argo stops working. So now it should be installed, and we can quickly check that by going to localhost, which is where I exposed the Argo UI. Let's hope it starts in a bit. Yes. So as you can see, this is the Argo UI, but there's nothing really interesting here just yet because we haven't started any workflows. So now let's go into the core concepts of Argo, which are workflows and templates. So a workflow defines the execution of one or more templates. And a template can consist of one or more steps. So in this case, a step can be a Docker container downloading some data from a database. It can be a container doing some processing and taking that data and maybe extending it with some additional meta information. Argo doesn't care what you do inside of your containers. It just defines the execution of that workflow. So it will ensure that if you say, I first want to fetch the data and then I want to do some processing on it, that those will run in the correct order. And that if the fetching of the data fails, that it won't try to process the data. Additionally, Argo has a whole templating language, which allows you to make your workflows a bit more generic, to use templating variables to change the behavior of your workflow without having to edit any code. And each step in your workflow can also define an input and output. That input can be an artifact, such as like a file or some set of images or whatever. And your container can process those images or process that file with some data, and then it can output that. And then Argo knows, hey, this step in the workflow outputted a file, I'll pass it along to the next container.
Lena, there's a question.
Yeah.
What Kubernetes are you running? Locally or cloud or which one?
That's a good question. I'm using Kint, which is Kubernetes in Docker. So it locally starts up a Docker container, and in that Docker container it installs Kubernetes. So eventually you'll be running Docker containers in Docker containers. But what I really like about Kint is that it starts up in like a minute. So I have a cluster running in a minute, which is why it's my preferred local option. Hopefully that answers the question.
Yes, perfect.
So let's get into the first example, obligatory hello world. But it showcases the workflow spec quite nicely. So as you can see, I'm defining a workflow here. The workflow has an entry point, which is the starting point of your entire workflow, which is will say. And this references a template named will say. And what does will say do? It runs the Docker will say container, which is, as you'll see, a container that does nothing else than just print a word and a nice will ASCII art. And it defines an input. And the input parameter is in this case named message. And as you can see, I'm using the Argo templating language to pass that message along to my container. And additionally, the workflow defines the default value for the parameter, which is in this case hello world. So let's go to the example. We're going to run the workflow, and we'll do that using the Argo CLI. So first I'm going to run it without overriding the parameter, and then I'm going to show you that you can also easily override that parameter using the CLI. So as you can see, I submitted the workflow, and you see it will stay in container creating quite a little while, but that is because it's still downloading the Docker will say container into my local cluster. Hopefully subsequent runs will be a lot quicker. So let's go to the Argo UI. You can already see that there is now a hello world workflow starting. You can see the YAML definition here as well. So you can see what was submitted. Oh, it completed, that's nice. So now we can actually see that the container run and nicely outputted a whale saying hello world. So let's now try to override that parameter and instead of hello world say something else. So let's say goodbye. So again, submitting the workflow. This time I'm expecting it to run a lot faster because the container is already downloaded. So we can check it here again. You see it's completed, and now we should see a whale saying goodbye. But obviously that isn't the most interesting example. So let's do some pod racing for whoever saw Star Wars. Sadly, pod racing in reality is not as exciting as the movies. What we're going to be doing is we're going to, hopefully, let me make that a bit bigger. We're going to be racing some containers against each other. We're going to, in parallel, execute two containers and see which container completed first. So we're going to introduce a bit of new syntax from Argo Workflows, which is the DAG syntax, Directed Acyclic Graph. So one of the really nice features of Argo Workflows is that you can define complex workflows where certain tasks depend on each other. So as I mentioned in the beginning, you can first make sure that you fetch the data before you start processing the data. In this case, I have a couple of containers, and they will just execute a simple busybox bash shell. And what we will run the containers in the following order. First, we'll start with a start container that will just echo a countdown. Next, we'll run two containers called Anakin and Sebulba, and those will be racing against each other. They will first report when they started, and then eventually we will run a finish container that will wait until Anakin and Sebulba have completed, and then we'll finish out the completion time of both containers. So let's run this in my terminal, if I can find my terminal. So as you can see, this will take again some time because I'm now, oh, it's already going. I need to load BusyBox into the container, but as you can see, it will start with the start container, then it will run Sebulba and Anakin in parallel, and we can see when they started.
Who won?
Yeah, that's what we're going to see when the finish container runs, because they both have to finish, and then we'll see that in this case, Anakin finished slightly before Sebulba, just like the movies. One really interesting note is that Argo automatically injects information about the completion of the previous containers and makes that available in the next steps in your workflow, which in this case I'm using to report on the completion time of the previous steps in my workflow. But you can imagine that this can be quite useful for certain metadata and certain monitoring capabilities in your workflow. One thing, there's an additional way how you can define this. So I showed the DAG syntax, the Directed Acyclic Graph, but Argo also supports an, in my opinion, really terrible looking syntax which uses double dashes and single dashes. So in this case, I'm defining a template named pod racing with multiple steps, and double dashes indicate, in this case, that pods will run sequentially, and single dashes will indicate that they run in parallel. So same thing as before, we'll start, then Anakin and Sebulba will run in parallel, and then finish will run after Anakin and Sebulba have completed. So let's run this example as well, just so you can see that it's pretty much the same thing. So go to the Argo UI, and as you can see, it starts with start, then it will run Sebulba and Anakin in parallel. And then once those complete, it will run the finish container. And then again, hopefully we will be able to see who finished first by looking at the logs of the finish container. And in this case, it was Anakin again. So I guess the movies were right. So one other really nice feature, and this is probably one of my favorite features of Argo Workflows, is the ability to pass files between containers and between steps of your workflows. So you can imagine that you're doing some machine learning workflow, and you first want to create a file with some maybe some annotations, or maybe some you do some data engineering and get the data in a format that your machine learning model understands, and then in the next step of your model you will train your machine learning model, and then the output of that step will be, of course, the machine learning artifact, and you can pass that along to the next step that deploys that machine learning artifact to some machine learning serving. Yes, I see there's a question.
Yes, I still have a question with regards to the previous race.
Yeah.
Stein is asking
I'm not sure if they indicate nested list in this case. Yeah, it could be.
Could be.
I'm not sure, but to be honest, I'm not a big fan of the single and double dashes because it feels a bit wrong to put two dashes after each other. I personally prefer the actual explicit dependencies that the DAX syntax uses. But I'm also somebody who comes from like an Airflow background, and in Airflow you specify workflow tasks depending on each other, indeed with like a similar explicit dependency. So sadly, I'm not sure if it's a nested list. You could probably look that up in the custom resource definition of the workflow.
Would it matter?
No, probably not. That's like a detail to Argo internally. So let's get back to the artifacts. What I'm going to show you is how in Argo Workflows you can download files from an external file storage into your workflow without your workflow even having to be aware where it's downloading those files from, and then passing a file along in the workflow, so passing them from step to step. So to do that, I'll first install an artifact storage in my cluster, which is minio. Minio can be seen as S3, AWS S3, or Azure Blob Storage, or Google Cloud Storage buckets. It's comparable to those, but it has the advantage that I don't pay for it and it runs in my Kubernetes cluster locally, so I don't have to set up any AWS credentials. So while that's installing, I'll quickly go over the setup. So for Argo to be able to use artifacts in its workflows, it of course needs to be aware of where it can use, how it can use these artifacts. So as you can see, Argo will use the bucket called Argo Artifacts as a temporary storage for my artifacts. So for the artifacts passed between steps, it will go to minio 9000, which is the artifact storage I'm running in my cluster, and it's using some credentials, obviously, to connect to that artifact storage. I'm also going to load a CSV file to minio, so I'll go to the minio UI quickly, so you can see how that looks. I'm running minio on 9000 locally, and I'll log in with some great usernames. So locally, you can see now there's an Argo artifacts bucket, and the CSV orders, orders.csv I uploaded just now can be found in the CSV orders bucket. So now I'll show how you can use that in your Argo workflows. So we're going to run a workflow using consisting of multiple steps, and the template is called artifact example. It will first echo out the CSV, then it will do some data engineering, and then again it will print some output. So the echo CSV template, and here's where it gets interesting, references the CSV orders bucket in minio. So as you can see, I'm referencing minio, I'm passing some credentials so that it can fetch the file, and you can see that I'm defining the bucket and the key where it can find that file. What Argo will do for you is it will download that file for you and inject it into the file system of your container. In this case, it will mount it at /orders.csv. Inside my container, I do nothing else than cutting out that orders.csv and moving it essentially to a different location. It's a demo. I didn't want to do any actual great data engineering. And as an output of this template, I'm defining, again, that orders.csv. So I'm defining an output artifact named orders.csv with the path temp orders.csv. And in this case, what Argo then will do is it will take that order CSV and move it to the Argo artifacts bucket so that it becomes available for the other steps in my workflow. So the next step defines an input, but in this case, it doesn't define where that input comes from. And I'll show you later on how you then pass that output from the previous step. So again, it defines an input named order CSV, which will be mounted at /temp/orders.csv. And what it will do is some bash data engineering. It will read each line from the CSV, echo that line with some text, and output it to the really useful report that we will send to our business stakeholders. And then of course we need to define an output artifact again, which is now called out text, and we'll fetch the out text from /temp/out text. And then the final step, again, we define an input, in this case a file named output on /temp/output, and we will just cut that out in our container. So let's run this example and go to the workflow. So you can now see here that there's like a, in the Argo UI, that this step defines an output called order CSV. Oh, I completely forgot to show you actually how you pass those artifacts. So within the, within our workflow, you pass the artifacts by reference using the Argo templating language. So in this case, you can see that I'm to the data engineering template. I'm passing an artifact named order CSV, and I pass that from the previous step, which of course also has a named output called order CSV. And again, same thing with print output. I'm passing the artifact output from, or by reference from the previous step, which is a named output called out text. And as you can see here, each step shows what output artifact it defines. And eventually it will come to the output container that will nicely log the results. And this just shows each line of the CSV I uploaded initially to Minio. So, because we don't have a lot of time, that was it for the demo section of my presentation. I wanted to quickly mention some other really cool features of Argo Workflows. One of my favorites are loops and conditionals. If you ever try to do this in Airflow, it's like almost impossible, and Argo natively supports it, and that is quite useful. For example, when you want to define a job that has some needs to do some conditional processing. So for example, if I want to backfill historical data, I can conditionally say, okay, load all data instead of load only the data of today. And loops are useful, for example, when you don't know how much data you will be processing. So you can just loop until all data is processed. It even supports recursion and memoization. So that can be useful when you have some complex processing to do and you need to calculate intermediate results, but you don't want to accidentally recalculate those intermediary results over and over again. Argo can store that for you and pass that along to your recursive workflow. And a final feature that is worthwhile mentioning is sidecars and daemon containers. So next to your workflow, you can run other containers. So for example, I can run an ambassador container that abstracts away whatever monitoring system I'm using in my cluster, and my workflow containers can talk to my ambassador, and that ambassador can send it to Prometheus or Datadog. And there's other use cases for sidecars as well. What is also really interesting to know is that there's quite a few projects that build on top of Argo Workflows. So most notably, I think, is Kubeflow. Kubeflow is a machine learning framework built on top of Argo Workflows. So it allows you to define in Python a few steps for like processing machine learning models. So it allows you to define steps for pre-processing the data. It allows you to define steps for training and hyperparameter optimization. And it allows you to define steps for eventually uploading the machine learning model and uploading that to some machine learning serving component. And under the hood, it takes your Python code and turns that into an Argo workflow running inside of your Kubernetes cluster. SQL Flow is actually quite similar in concept to Kubeflow, where Kubeflow uses Python. SQL Flow takes a SQL statement and uses that to generate an Argo workflow that fetches the data from a database and then runs a training job on top of that data. And the final project built on top of Argo that is worthwhile mentioning is Couler, and Couler is trying to build a unified workflow engine API. So you have Airflow, you have Argo Workflows, you have AWS step functions and many others. And what Couler is trying to do is trying to create a unified Python interface so that theoretically you could switch between Argo Workflows and Airflow by just changing some configuration. And that was it for my talk about Argo Workflows. I hope that everybody enjoyed it.
All right. If you have any questions, please ask them in the chat. We'll be switching laptops and speakers, and I think also a cable, because we had some black flashes. So not with Peter's laptop.
Not with mine.
Lennart, what would you say to a client that has everything now done in Airflow? Would you advise to step over to use something like Couler or?
I would like it really depends. Obviously, it's not realistic to say to somebody, "Hey, you spent 2 years creating Airflow jobs. Let's now all change it." That's not realistic. What the main benefit of Argo Workflows is like it has a bunch of additional features over Airflow, and it doesn't use Python. So because it uses containers, you're not going to run into issues with like, hey, I forgot to, I've imported the wrong Python library and now my entire Airflow instance is messed up.
So with Couler you could actually have a strategy to leave the old Airflow, and then build on top of that new Argo Workflows to get new features.
Yes, yeah, that would be nice if you could indeed have like a unified interface that allows you to switch over implementations.
Okay, I still hear a small could, so...
Yeah, like Couler is quite a young project, so they only support Argo Workflows at the moment.
Okay, open source?
Yeah.
Cool.
They have the ambition to support Airflow, but at the moment they only support
So it's
Argo
cool to commit to Couler.
Yeah.
Perfect. All right, I think Peter?
Yes.
You will tell us something about time, right?
Well, it depends how you define time, but
It's temporal.
yeah, it's temporal.
All right, then hit it off.
Okay, thank you. Well, my talk is about temporal, which is a different concept. If you look into Argo CD for Argo, it's just different. Okay, first a little bit about me. I should move to the middle. I'm also a data engineer at DataWorks. Currently I work for the IRS, the Dutch IRS field. If I find your name, you're in big trouble. So please don't do any crazy things with financial fraud. Furthermore, I'm just enjoy the water and doing things on the water. Okay. I'm going to start out about talking a little bit about what products, what it's not, and that's, I think, even more important. And then I go into the concepts that are known within temporal. And when I started working with temporal, the concepts that was killing me in the beginning, because I didn't understand what the different concepts were and how to use them. and then we'll finish up about temporal with a small demo. Okay, if you look at the website and you read the promise from temporal, you see a lot of words, and it says complexity and distributed and all kinds of buzzwords, all the buzzwords you can find about workflows and doing things. It's just another workflow manager, and that's it. So don't read the promise that they give, but just be simple and say, okay, it does something, it could solve a problem for me. Temporal is not new. It was originally from Uber. It was called Cadence, which is still available. Some of the main developers from Uber went to build their own system, and they took up the origin of Cadence and they added some additional clients.
Slides if you take so much time on that one.
No, it's not that many slides.
Sorry about that. We'll continue.
We'll continue. What they really added to the system is some security features, so TLS and similar. Their error handling or their failure handling of the activities, they've changed quite a bit on that one. And there's a lot more information in the failures that you have, and they're not storing binary blobs in a database, but just and really use a protocol to store all that information. Just the history, but it's important to understand what temporal is not. It's not a DAG system. Like in Argo, you can define DAGs, and the DAG has a beginning and has an end. It's not what temporal can do. It's not a business process manager. They state that quite clearly. So, okay, we're not doing business process management because that has all kinds of other problems that they don't want to fix. It's not a JSON-based workflow engine like AWS step functions. It's not that. It's different. But before we go into to a small demo, I want to explain the concepts of when working with temporal. And for me, it took me some time to grasp what all those different concepts were. And once I understood those concepts, it was fairly simple to get on with doing stuff. Okay, we got a bunch of words that they used throughout the documentation, which is just the temporal system. They got actors, activities, workflows. They talk about events, task queues, and namespaces, and fault handling mechanisms. Those are the words when you start reading the documentation, you get hammered with it. So temporal, the system, it's just the core of the engine. It if you deploy that one, it will start a few pods, and one of the main pods is temporal itself, and that connects to a Redis database, and that's where all the magic happens on controlling the state, starting activities, workers, and things like that. That's all it does. I'm not going too deep into the details of the system and how it works, but this is the basics of the system. If you don't have this part up and running, nothing will work. When you first start reading the documentation, they say, well, we've got an actor framework. But if you read on into the documentation, the word actor is never mentioned again. It's always a worker. And when you go to the code samples, they talk about workers as well. So be aware that sometimes they use actor, but in general they use workers, the term worker. And the actor or the worker is actually the process that executes the workflows and the activities, which is just a pod running. If you run it on Kubernetes, it's just a pod that accepts incoming requests to do something. If you have a worker, when you start that one up, it has information in itself to define, okay, I'm able to accept requests for this workflow, or I'm able to execute these activities. And that could be all the activities you have defined or a small portion of it. Temporal just wants to know, the system wants to know, okay, I've got a worker and he can run workflow A and activities B and C. And on another pod, it runs other activities and or workflows. It uses a queuing mechanism to start workflows and activities, and those are all managed by Temporal itself. And as I already mentioned, it can be scaled. You can have a number of pods or workers that do work for you, and Temporal just figures out, okay, I've got 10 pods running. No, it doesn't even know you have pods running. It knows I've got 10 systems that can execute a workflow, and 8 of them can execute 90% of all have 90% of all the activities, and the other 2 have the other 20%, 10% or 20%. So that's what a worker can do. The workflow is the basics of everything that you do within Temporal. And you can represent the workflow in code on all the steps that it needs to take. If you have a workflow with multiple things in it, all the state of the workflow is saved within Temporal itself. So if a process crashes, the Temporal server knows where it was, and when a pod comes up again, it can restore the workflow to the point where it knows where it was. Anything doing about threads, timers, and helpers, it's all done within the workflow. The library provides you a lot of information, functionality for that one. And maybe that's a little bit different to Argo, because I haven't heard anything specific about that one. But a workflow can be running for days, weeks, or even months. Temporal just remembers, okay, this workflow was at that stage and I'm waiting for something to happen to continue the workflow. Other things that are important to know that are events. Events can send a signal to a workflow. And for example, if you have a workflow that waits for some user action to confirm that a certain form is signed or anything like that, you can send the event to restart or make the workflow continue. We have task queues, and the task queues I mentioned them before. The task queues have just events on that, and Temporal uses them to distribute all the work throughout the system. You can use namespaces if you want to, so that specific workflows execute within a namespace. Later on, I will give you, during the demo, I'll show you a little bit about that one. But then you can group and cluster certain workflows, just for your own knowledge. Okay, demo time. Let's hope our system is happy about that one. I should start top to the system. Okay, here I just have a terminal. I'll make it a little bit bigger, even more. If you want to start working with it yourself, it's fairly easy. I just cloned a repository from Temporal itself, which just contains some Docker Compose files. And if you don't do anything and just type in Docker Compose up, it will start up a few processes, Cassandra and Temporal itself. It will take some time before this one starts up because it has to wait for Cassandra to start up. But once this is running, you have a instance of Temporal running. Oh shit, I have to look where my browser is. Here it is. There's a website available for it, and there's nothing much in it. It has a few of all the workflows that you have executed or not. A page for settings, and that more or less resembles how you deployed Temporal. And here in the top you can see I'm using just the default namespace. For this demo I'm just using the defaults. Okay. But we want to know how it all works. If you start programming a workflow, it all begins with just an interface. The interface has two annotations. It needs, on class level, you need to define a workflow interface. And there has to be at least one method in it that says add workflow method. That is for Temporal the entry point of your workflow. So whenever you want to start this workflow, it will start with the method process file. In this case, this is a very simple example just taken from Temporal itself, but it helps to prove the point how it works. The next thing, because we have a workflow, but in a workflow that we have activities. And the activity is, again, just an interface with the annotation activity interface. And it has, in my case, a few methods in it. These methods are available within the workflow to be executed. He knows, okay, this is an activity and I can do something with that one. The other part is just used for housekeeping in the system. Okay, we'll start with the simple one first, and that's the implementation of the activities. Because this sample, what it does, you send a URL to the Temporal system, and it will download the file with whatever you download as specified. So here we have a method, download, it goes, it just does a download of the URL. It processes the source file, and then the process file implementation is just, okay, read out whatever you read from the HTTP endpoint and write that to your file system. That's all that's to it. Okay, cool. So I've got activities. I define an interface for the workflow. Now we start implementing the actual work, the process that you start up in either a pod or whatever you want it to be, so that it will actually execute the workflow. The first part of the code is nothing more than, okay, I want to, there's a trick here in that it tries to run everything within the same node, but you make a connection to the workflow server, you create a client here, and we say, okay, I've got a worker factory. The worker factory is just the object that you need to have to register your workflow and the activities you want to run. I say, okay, I've got a new worker and I'm going to listen to a specific queue or a topic, depending on where you come from. And then I say to the system, okay, register this workflow implementation. Temporal, the library that's beneath this one, will instantiate this class and register that one to the temporal server. The next thing is I'm going to instantiate a class or an implementation, an object of my activities implementation, and those I'm also registering to temporal. Okay, now temporal knows, give or take, everything it wants to know. And then I say, just start. This is a background process. This is just a simple main class. It will never stop. It will keep on running. And when you start this one, it will listen for events on the queue I specified here. Cool. So when I start that one, you can see here temporal is just waiting for me to do stuff, or waiting for tasks to do. Now I should be... Okay. Now I should have not that one. Not that one. Where is he? I'm going to do this differently.
Peter, it might be a typo in the beginning.
Yeah, that's not correct. I have to figure out which command I need to run. Because I thought it was in my history, but it's not. This is just a Cradle command to start my worker. When I start that one, it's executing, it's waiting. There's not a lot of the logging you can see here. Maybe I can. It's creating a client to the server. It defines, okay, I'm polling for information from the server, and that's it. That's it. So here it says, and that's just logging that's built into the application. Okay, I've started a worker for a specific task queue, and I have activities on a specific task queue as well. That's all that's to it for the worker. Okay, that's all nice and fun, but now what? It's just waiting. We need to send information to it. Before I figured that one out, if you read the documentation and you know what you're doing, you're like, oh yeah, simple, it's there. But it took me some moments to figure out what actually went on there. Because you need what they call in the documentation a starter. You need to send information to temporal. Okay, you need to do something for me. And that's what in general they call a starter. And it does nothing more than placing a single message on a topic. The only thing that they really want you to do is to make sure that the message you put onto that topic is serializable. Because yeah, it needs to be transferred between JVM paths and other systems that you need to know. Again, we make a connection to temporal. We create a client. And we say, okay, I want to set something on a specific topic queue, and we want to execute this workflow. So you say, okay, I've got topic A, and I want to process, I want the workflow, in this case, file processing workflow, to be started when I'm done here. So what it does, it just takes a URL source and destination, and then we just say, workflow, start processing this file. And this is a synchronous call, so it will wait for the completion of this workflow. But it will not be executed within this piece of code. So I can show you that one. I need to execute, copy the command again. So if I run this this application, the starter, it starts dealing. Yeah, it needs to compile everything, and it says, "I've done my job." And you say, "Okay, yeah, cool. Well, what happened?" Now I need to find my other terminal window. There it is. I'll kind of show you the same thing but next to each other. Where's my other terminal? Not that one. I always have, I'm fighting with terminals right now. I'll just make a new terminal. No, it's not gonna help. There it is. I'm just gonna fire up a new terminal next to this one, because this is the starter. You can see here it's the actual worker is waiting for work. If I start here the process, I should go to the correct directory. Nope, I'm already there. That one. And here you see that it started downloading from google.com. It saved it, the file to a temporary folder, and you can actually see here in the right window, for you probably on the left, I started the workflow, and it was executed by the worker itself. For so far my short demo, I'm a little bit jealous of my predecessor here with the big demo he created. Okay, this is temporal in a nutshell. Writing workflows, it sounds easy, but error handling is hard. Yeah, temporal has all kinds of mechanisms to handle failures in your activity or in your workflow. And you can say, yeah, well, if you fail, just do a restart. But if you throw an exception, it will restart. But will that exception be resolved if I retry it, or is it just a permanent failure? So that's a thing you really have to think about. Okay, what am I going to do with error handling? An activity should never end with an exception to make sure it ends on a nice, clean way. I'm going to show one more screen, and that's this one. You can actually see what happened and what was passed in the processing. We had a workflow name. It started January 16 at 6:17 p.m. It was completed. It had an ID. It had a run ID, and this was what I sent to it, what I put onto the topic, and this was the result. In this sample, it's very simple, but with this viewer, you can actually can see quite a bit of what happened. If you have an error and you go to the stack trace, I don't know why this one says it states this one right here right now, but you can actually see, okay, that went wrong. You can also see some historical data on workflows that were executed, because this was the one we just executed, and earlier today, let's see if I can find another timestamp. I thought I saw a timestamp. Sorry. So there's all kinds of information available within this browser. There's a command line tool for it as well to browse to namespaces, workflows, activities, and how they're managed. Okay, that was the runtime. There's two things I want to mention, but just as a side note. It has Saka support. and that's a fairly, well, it's quite an old paradigm, but it's recently being more and more introduced. If you have a workflow that stores something into the database, and 4 activities down the line, you're like, oops, I made a boo-boo. With the Saga support, you can use that one. Okay, in activity A, I did this step, and this is the rollback for it, and that you can accumulate all those. And when you have the exception, so that you have to roll that one back, it's fairly easy to do. But yes, you do have to program it yourself.
It's not built into temporal itself. You need to use Saga then.
You need to write your own rollback methods and what it needs to do in that one, because you need to specify, okay, if you do a rollback, you need to execute these and these commands, but it has the mechanism within the system to make sure that that one is called when you fail. But you still have to, you still have to write something for it. But it has some nice wrappers around it, so you can, fairly easy separate them from, okay, this is actually what needs to be done. Oh yeah, by the way, this is the rollback. You can separate those two. If you have a system that needs some kind of auditing and long-term storage of everything that happened within your system, they have an archival system, which is just offloading all the workflow and everything that has been done in that one to an external storage. This was the Saga support. You can find it at microservice.io. There are quite a few more statements on that one. These are the links. If you want to get more into temporal I/O, have a look at these links. It's all based on all source code that I've used and shown you can be found on the GitHub account of temporal I/O, and just the project's temporal samples either Java or in Go, whatever your flavor is. I don't even think they have PHP or Ruby examples, but I haven't checked on those two. And if you just want to read the documentations, go to temporal I/O. Everything will be found there. Any questions?
I didn't see any questions so far.
Okay. Good.
So I think we're on the end.
Yes, we are.
If you still have any questions, please send them in the chat, and then we can answer them via mail.
Yes.
Maybe one last question that when we had now these two workflow engines discussed, when would you use either temporal and when would you use Argo?
I think it's always a little bit arbitrary if you choose either A or B. If I look at Argo, it's more declarative in that sense. It's more just a configuration file where you specify, okay, I want to start pod A and there's a small processing that I do. In each one, they restart the pod. A pod is spun up within the Kubernetes environment. So if you have pods that start up really fast, go for it. If your process is really fast, go for it. If your processors need to have more resources in order to do their thing, like database connections that need to be initialized, connection pools, file storage it has something for that, but if it needs a lot of I/O and it takes a long time to start a certain pod before it can actually be used, I would go for temporal because that is more of an active standby, while Argo is a cold standby.
I think the active standby statement is indeed like the right thing. For me, temporal has like really strong rollback support, really strong asynchronous support.
Yeah.
Whereas Argo is more focused on executing containers in sequential order and ensuring that you can do indeed artifact passing, but it doesn't do a lot with regards to failures, rollbacks.
And I think temporal is a lot better, or I don't know if it's better is the right word, but it has a lot more tooling around the error handling itself in general.
Applications in general, I'd lean more towards temporal.
Yeah.
It's more flexible.
It's very flexible. I think it's more flexible than what I know and seen of Argo. I think it's a lot more flexible because, yeah, you have either Java or Golang to do your things, and I don't know how that is within Argo. If that's
it doesn't enforce anything.
Yeah.
It's running containers.
Yeah, it just spins up a container and yeah, whatever you want to do. So yeah, I think those mainly error handling and keeping state. I think that's the big the big plus for temporal. And if you don't need it, go with Argo.
Right.
But there are plenty of other workflow managers. I worked with Spring Dataflow, which for us didn't work because the startup times were too slow. Because since we moved, we had an implementation based on Spring Dataflow. We migrated to temporal, and we're now a factor 70 faster.
So it was speed why you went for temporal in the end.
Yeah, speed and performance.
All right.
That's the big boss of us.
All right, I think we're
He wants
finished.
attention.
Oh, no, there's one more question.
One last question.
Can it replace Kafka, or is it pushing it too much?
Can it replace Kafka, or is it pushing it too much?
It can, but it depends. What are you doing with Kafka? Are you doing Kafka streaming? Kafka streams? Then you could replace it with temporal. But you should really look into your implementation if it's beneficial to do that, because it's not a yes or no question.
It depends.
Yeah,
It depends.
Yeah, but and it really depends. Okay, what do I want to achieve, and what kind of certainty I want to have? With temporal, it gives you all kinds of archive stuff and retry stuff and things like that. If you do Kafka streams and you get an error, you gotta fix it yourself. Yeah. There's no replay, or if an activity or a part of your stream fails, what can you do? Does it fail? Do you drop that message? I don't know. And that's the big depend part in it.
Good question to take home. So I think we're finishing.
Yeah.
Thanks a lot, everybody, for stopping by. I think we've been doing these virtual meetups now for a year. It's unbelievable.
Yes.
I hope we'll soon have a live meetup back in our office, and I hope to see you there in about 2 months, because that's the regular time frame when we do the meetups. Thanks a lot for coming, and bye-bye.
See you next time.